Okay, we're going to start talking about something called Rolle's theorem. We're going to use it to locate horizontal tangents to a curve. So a little bit about Rolle. He was French, and he started out hating calculus. He didn't see the reason in it. He thought it was a bunch of guessing. But later he went on to publish his theorem and said calculus actually is kind of useful. So he ended up as one of the main thinkers of calculus. But his theorem starts out like this. So on your paper, on the graph, try to connect the dots using any function that is both continuous, which means there's no breaks, and differentiable. So no corners, cusps, jumps, anything like that. And so if you do that, no matter what you do, you're going to have somewhere on your graph where you end up with horizontal tangents. Even if you were to draw your line perfectly horizontal, then the line itself is a horizontal tangent. So the question, is it possible to connect the dots without creating a horizontal tangent? The answer is no. The only way to do that would be to break continuity or differentiability. And so he saw this and he... sorry about that. My iPad died. But if we use that, then we're going to use his theorem to help us answer some questions. So his theorem says, suppose f of x is a function that satisfies all the following. It is continuous and differentiable, and that f of a is equal to f of b. So if you go back to this, my value of f of a is equal to f of b. That is important because if you simply increase the whole time, then you don't really have to have a horizontal tangent. So he says, if that is all true, these three things, then there must exist a number c somewhere between a and b where the derivative is 0, or in other words, where we have a horizontal tangent. And so if we look at this graphically, if I have 2 points, A and B, and I connect those 2 points with something that is continuous and differentiable, then it either has to be horizontal, like the red line, or I have to at some point have a horizontal tangent no matter which way I go at least one time. It could be really an infinite. So if you think about sine or cosine, those have multiple horizontal tangents. So that's all good, but let's see how this actually works. So, for example, the question might say, find the value c that satisfies Rolle's theorem for the function. The way I remember Rolle's theorem is because of the O in his name, so it's where the tangent equals 0. So I want to find the value c that satisfies Rolle's theorem for the function. So if I'm going to do this problem, I have to first be sure it meets these conditions. So it's a polynomial, it's a parabola, so it's going to be continuous, it's going to be differentiable, but I would check those two things. So I would say it is continuous and it is differentiable on 0, 3. And so now I'm going to check the last condition, and that is that my values are equal. So if I go back to this, if I should probably draw. If I need to see, does f of 0 equal f of 3? And if I put in 0, I get a 7. If I substitute in 3, I get 9 minus 9 plus 7, which is also 7. So 7 equals 7. So it's continuous, it's differentiable, and it's equal at my endpoints. So now I'm looking where the slope of the tangent is equal to 0, which would mean I'm looking for slope, which tells me in calculus terms to take a derivative. So if I take the derivative, I get 2x minus 3. And I want to know where does that equal 0? Well, that's going to equal 0 at 3/2, or 1.5. So it doesn't ask me for the point, it asks me for the value of c. That would be your x value. So I would say it satisfies Rolle's theorem when c equals 3/2. And if you want to check that, if you graph this in your calculator, you'll get a parabola, and you'll see that it has a minimum at x equals 3/2, which is where the tangent would be 0. So this next question asks us, Rolle's theorem can be applied to the following function, so we're supposed to say whether that's true or false. So we have to test the 3 conditions. This is a parabola again, so it's going to be continuous, it's going to be differentiable. So the only thing we need to see is, does f of negative 2 equal f of 3? And so if I wanted to check this, if it were a calculator question, I would certainly use my calculator. Sorry. But if it's not, I'm going to try this by hand. And so if I were to work all this out, either by hand or on my calculator, depending on what section of the test this was on, I got 22 and 7. So the reality is that f of negative 2 is not equal to negative 3. So the conditions, is it continuous? Yes. Is it differentiable? Yes. But are the endpoints equal? The answer is no. So therefore, it does not meet the conditions. So could there be a tangent of 0 between negative 2 and 3? Yes, absolutely. But there does not have to be. So this one, same deal. Can it be applied? It's asking about the 3 criteria. So the first one, is it continuous? The function 1 over x squared is not continuous everywhere. So it looks like this. So at 0, right here's my problem. So if that falls in my interval, that's going to cause a problem. It does fall in my interval, so it's not continuous, which means we don't have to continue the other criteria. So since it's not continuous, the answer is false. No, it cannot be applied. Okay, again, same type of function, same deal. Is it continuous? It's a cubic, it's going to be continuous. Is it differentiable? Yes, it's a cubic, it'll be differentiable. So then the question is, does f of negative 2 equal f of 1? So if I do negative 2 cubed plus negative 2 squared minus 2 times negative 2 plus 2, does it equal 1 cubed plus 1 squared minus 2 times 1 plus 2? And so I got 2 and 2. So since they are equal, it's continuous and it's differentiable. This is a true statement. Rolle's theorem could be applied to this problem. Okay, this problem, a little more complicated, but it says find the values of C that satisfies Rolle's theorem. So we first need to check it is continuous everywhere except for -1, but -1 is not in our interval, so we're okay. It's also differentiable. So we need to check, does f of 0 equal f of 5? So if I put in 0, I get -2/1 or -2. If I put in 5, I would get -12/6, which also reduces to -2. So it meets all three conditions. So we're going to go ahead and use it. But in order to find a tangent, I need a derivative. So this is a quotient. So we're going to use our Hi-Ho formula. So it's the Hi-Ho minus Hi-Do over Ho-Ho. And so I know a lot of times we talked about it's not necessarily clean this up, but it would be helpful because we're going to set that equal to 0. So unless you know what that is equal to 0, we need to clean it up some. And so if we clean up this first part, we get -2x squared minus 2x plus 3x plus 3. And then the second part, multiplying by 1 doesn't change it, but we do need to distribute a negative. So it's plus x squared minus 3x plus 2. And that's all over x plus 1 squared. And so I would get a negative x squared minus 2x plus 5 over x plus 1 squared. And I want to know, when does that equal 0? Okay, so this is a rational. The reality is I don't care, if I'm looking for where the rational equals 0, I don't care about the denominator unless the value I get causes the denominator to be 0. But we already said that that's going to happen at -1, and -1 is not in our interval, so we're good. So we're going to take the numerator, and we want to know, when does that equal 0? Well, that's not going to be factorable, so I'm going to use the quadratic formula. So it's -b plus or minus the square root of b squared minus 4ac all over 2a. And so if I clean that up, I should get, if I reduce, I would get 2 plus or minus over -2, and that works out to actually be square root of 24, I believe. And 24 reduces to 2 square root of 6. So that reduces further to 1 plus or minus the square root of 6. But my interval was 0 to 5. So if I do 1 minus the square root of 6, I'm going to get a negative number. So I only want the plus version. So the c would happen, the x or the c, because the problem asks for c, occurs when c equals 1 plus the square root of 6. So that one, more complicated because it's irrational. You had to use quotient rule. You have to know your properties of rationals. You also had to use quadratic formulas. So that's kind of a hefty problem. So you might need to rewatch the working of that one. And you certainly can go back, rewind, do whatever. Okay, so you surely didn't think I was going to let you get away with autorational, which we just did, or trig. So I gave you both. So the question here, can this be applied? Yes, because it is continuous, it is differentiable. And if we check the value of the function at negative 2 pi, or excuse me, yes, at negative 2 pi, which would actually be sine of negative pi, would be 0. And the value of the function at sine of pi would also be 0, because the 2's are going to cancel with the 2 that's in that equation. So it's continuous, it's differentiable, and they equal at the endpoint. So we can go ahead and find our c. So we'll do the derivative. So it's derivative of sine is cosine. And the chain rule causes me to get a 2. Instead of writing it at the end, I'm going to bring it out front just because I know it's going to be there. I want to know when this equals 0. So I divide by 2. Sorry about that. So I divide by 2 and I'll get cosine of 2x equals 0. So I want to know where does cosine of 2x equals 0. Well, cosine equals 0 at the pi over 2's and 3 pi over 2's. But this 2x in here makes me have to work a little harder. So if I want it to actually be pi over 2, then I would need to use the pi over 4's. So my answers end up being at negative pi over 4 and pi over 4. And that's because cosine of 2 times negative pi over 4 is 0, and cosine of 2 times pi over 4 is also 0. So those little trig, unit circle, and being able to deal with composite trig functions, super important. So it doesn't matter if you know Rolle's theorem, which is a calculus thing. If you can't do the pre-cal portion, then you're gonna get hit on the AP exam. Okay, that is the end of your notes. So you should have a worksheet that has 10 problems on it now. So I would like you to pause the video, work on those 10 problems. I am actually going to work out all 10. So if you find yourself, you want to check your answer, or you need help on a problem, you can fast forward, rewind to that problem, watch me work it, and hopefully I'll be able to answer any of your questions. So this is actually number 1 on the worksheet, and it asks you to find the values of C that satisfy Rolle's theorem. So before we get started, we have to be sure we can use Rolle's theorem. So I would look, is this continuous? It's a parabola, so yes. Is it differentiable? Yes, it's a parabola. So then I would check, does f of negative 5 equal f of 0? And the answer is yes, because they both equal negative 6. So it meets the conditions, so now I can use it. So if I'm looking for a tangent, I'm going to take the derivative. So 2x plus 5. I'm going to set it equal to 0. I'm going to solve it. And so I'll say this satisfies Rolle's theorem when c equals negative 5/2. Okay, number 2, is it continuous? Yes, it's cosine. Is it differentiable? Yes, it's cosine. So then the question is, does the value of the function at 3 pi over 4 equal the value of the function at 11 pi over 4? And if we put this in, this is actually because of the minus pi over 4. It's actually cosine of pi over 2, which is 0. And again, if we put in 11 pi over 4 and subtract pi over 4, we actually get 5 pi over 2, which is 2 complete rotations plus another pi over, or 1 complete rotation, excuse me, plus another pi over 2. So 0 does equal 0. You're good. So it's different, continuous, differentiable, and equal at the endpoints. So now we have to decide where the tangent is 0. So if I look at this, the derivative of cosine is negative sine. And even though there's this pi over 4 in there, it's a constant. It's not a coefficient. So derivative of x minus pi over 4 is still 1. So we're good. We're going to set this equal to 0. So I'm going to get rid of the negative. So I'll do sine x minus pi over 4 equals 0. Okay, so sine is 0 at 0 and pi, but we have this little minus pi over 4. So instead of it being 0 at 0 and pi, it's actually going to be 0 at pi over 4, 5 pi over 4, 9 pi over 4. So always a pi over 4 past what we needed. But I need to look at my interval. So my interval is from 3 pi over 4 to 11 pi over 4. So this point is before the interval. These two are within it. And if I were to go another, it would be 13 pi over 4, which is too far. So these two. So the answer then would be this satisfies Rolle's theorem when C equals 5 pi over 4 and 9 pi over 4. So there's actually 2, which should make sense because cosine and sine are periodic. They have a lot of horizontal asymptotes. Horizontal tangents. Okay, so on this problem, is it continuous? Yes, it's a cubic. Is it differentiable? Yes. So before we can use Rolle's theorem, we have to check to see if our endpoints are equal. So when I put in negative 5, I get a 0. When I put in 3 halves, I actually get 65 over 8. So they're not equal. So it is not possible to use Rolle's theorem. Could there be a horizontal tangent? Yes. But does there have to be? No. Okay. Number 4, it says we can use a calculator. So life is good. Is it going to be continuous? Yes, because it's cubic. Differentiable? Yes. So then the question is, does the value of the function at negative 9 equal the value of the function at 3? So if you put it in, you get negative 13 halves or negative 6.5 for both points. So we're good. So now we can take the derivative. So the 3 is going to cancel, so we get x squared. The 2 is going to cancel, so we get 5x and negative 6. So we'll see, when does this equal 0? We can factor this. So plus 6 minus 1, I believe that should work. So negative 6, positive 1. So it's equal to 0 when C equals negative 6 or positive 1. That one's pretty straightforward. Number 5, probably another one of your favorites. So is it continuous? Yes, except for at negative 6, but that's outside our interval. Is it differentiable? Yes, on the interval. And then are the values equal? We don't know, so let's try it. So if I put in negative 5, I get 10 over 1, so 10. Put in 16, I get 220 over 22, which reduces to 10, so they are different. It's continuous, differentiable, and the values and the endpoints are equal. So I can go ahead and take the derivative, which I know you're super excited about because you get to use quotient rule. So it's dhi ho minus hi de ho over ho ho. Again, there is value in cleaning it up now because we were about to have to solve it, and no one wants to solve all that garbage. So, I can clean this up if I could write. So I'm multiplying by 1 isn't going to do anything, but I do have to distribute that negative. So I believe I get this, which means I get x squared, 11 plus 12x, and plus 14. Over x plus 6 squared. Okay, so since this is irrational, I don't care about the denominator unless it causes me problems at my solution. But negative 6 is outside my interval, so I don't care about that. So I need to do this, and it is tempting to try and factor that. I can't think of anything to factor it to, so I'm going to try a quadratic formula. So negative b plus or minus the square root b squared minus 4ac all over 2a. So this negative 12 to plus or minus the square root of 88, which we can reduce to 2 square root of 22, I believe. So I can take out a 2, so I get 6 plus or minus the square root of 22. So the square root of 22 is going to be 4 something. So negative 6 plus 4 would give me a negative 1 something. Negative 6 minus square root of 22 is going to hit me back at negative 10, which is outside my interval. So I was actually looking for when c equals negative 6 plus the square root of 22. And again, you probably hate these because it's everything basically in math that you probably disliked. But it is a good problem to maybe watch the video on. Okay, cubic, so it's going to be continuous, it's going to be differentiable. So then we need to check our endpoints. And this is where we run into a problem. When I put in negative 3, I get a negative 5. When I put in a 2, I actually get a 0. So since negative 5 does not equal 0, it is not possible to use Rolle's theorem. Could there be a horizontal tangent? Yes, but there does not have to be. Okay, more trig, which you love. This time it's cosecant, which is especially great. So we're going to talk about this one. This is one of the ones at the top that's listed you can use your calculator on, so you better believe I'm going to graph this one to check on the continuity and differentiability. Just remember there's not a cosecant key. So when you put this in your graph, you're going to have to put 1 over sine of x plus pi over 2 and set your window from negative pi over 4 to negative 3 pi over 4. And your y's, remember cosecant is below negative 1 and above positive 1, so I would probably do negative 3 to 3, just to be sure. When you do that, you see that it is, this interval is cut off before any asymptotes, so we're good. It is continuous, it is differentiable, and so now the question is, does f of negative 5 pi over 4 equal f of negative 3 pi over 4. And these actually both are negative square root of 2. So it's continuous, it's differentiable, and the endpoints are equal. So now we can continue. So we're going to take a derivative. So derivative of cosecant is negative because it's a co. So it's cosecant x plus pi over 2 cotangent x plus pi over 2. And we want to know, when does that equal 0? Well, one thing we can take out pretty quickly is the negative. So you divide 0 by negative, it's still 0. Not a big deal there. Okay, and honestly, you get a calculator on this question. Let's not miss it because of our trig knowledge. What I would do is I would go ahead and graph that derivative and see where it's equal to 0. So if you graph that derivative and you find the 0, it happens at negative 3.1415, which should look familiar. So that happens at negative pi. You could figure that out. It's long, it's tedious. I wouldn't do it. I would just go ahead and do that. The way you could figure it out is cosecant, it only has a denominator. There's a 1 in the numerator, so we don't really care about that. Cotangent would be cosine over sine. So you're really looking for where cosine is 0, and the plus pi over 2 adjusts that. But in all honesty, you have a calculator, let's use it to our advantage. Okay, so this is continuous, it's a quartic, it's differentiable. So the question is, does the value at negative 3 equal the value at 3? The answer is, does 0 equal 0? Yes. So we can use that, Rolle's theorem. So I would take a derivative, so 4x to the third minus 20x. I want to know, when does that equal 0? So I would factor out a 4x and I get x squared minus 5. So it's going to be where 4x equals 0 or x squared minus 5 equals 0. So at 0 or positive, negative square root of 5. Those are all within my interval. So I'm going to say this works when c is 0 or positive, negative 5. So that one, much needed break from the others. Okay, this one, it's going to be continuous, it's a quartic, it's going to be differentiable. So the question is, does the value at negative 4 equal the value at 4? The answer is the value at negative 4 is 49 thirds. The value at positive 4 is 113 thirds. So those are not equal. So it is not possible to use Rolle's theorem on this problem. Could there be a horizontal tangent? Yes, but there does not have to be. Okay, so it's continuous except for at negative 4, which is not in our interval. It's differentiable on our interval. So then the question is, does the value of the function at 1 equal the value of the function at 14? So at negative 1, I get negative 18 over over positive 3, so I get negative 6. And if I substitute in 14, I get negative 108 over 18, which also reduces to negative 6. So it's continuous, it's differentiable, and the endpoints are equal. So I can take a derivative. So I decided to send you out with a quotient rule, which I know you love. So it's Dahai ho minus high to ho over ho. Again, there's value in cleaning it up unless you want to solve that goop up there. If I multiply by 1, it's not going to change anything, but I do have to distribute a negative. And I'm going to set this equal to 0. Oops, just a moment, if I can simplify correctly. So it's negative 1x minus 7, negative 8x, 28, 38 over this will equal it to 0. There is no way I want to try and factor that numerator. Real quickly, the denominator, I'm only worried about it negative 4, which is outside my interval anyway. So I'm going to use a quadratic formula. So 4ac all over 2a. So we get 8 plus or minus. This becomes the square root of 216, which we can break down into, what is it, 6 square root of 6, I believe. Yes, 6 square root of 6. So that becomes negative 4 plus or minus 3 square root of 6. So I have to look in my interval. So 3 square root of 6, it's going to be like 7 something. So my interval is negative 1 to 14. So I'm only going to want the positive version of that, or the addition version. So that would be my answer. And that was your last problem. So you're welcome to rewatch this video, or only watch certain parts of it. Whatever you need, just be sure you're comfortable.